Hi, in this lecture I will go over some examples of analysis of trusses. The first example I have is asking for the loads shown on the truss, use method of joints to determine the force in all the truss members. Indicate if there are tension or compression. Okay. Method of joints. It is asking about method of joints. Remember, method of joints, the step one is draw free body diagram of a joint, and we usually start from a joint that has two unknowns, so we are able to do it. When you look at this truss, B has three unknowns, A has three unknowns, or B even has four unknowns. E has 1, 2, 3, 4 unknowns. C has 3 unknowns. D has 2 unknowns. So we start from free body diagram of joint D. Step 1, isolate the joint. So I'm drawing point D. Step 2, put active forces on there. I have a 600 newtons in horizontal direction. Then put reactive forces. Reactive forces are forces in member DE and member DC. Since they're unknown, I am going to draw them as tension. So I'm going to put FDE and I'm going to put FCD. Remember, for the unknown forces, my method is to put them always in tension, meaning going away, tension, going away from the joint. Okay, for unknown only. Okay, and as we discussed, this is similar to being a particle, equilibrium of a particle. Then we have summation of forces in X and summation of forces in Y. So let's establish axes here, X and Y. And this force DE has a slope triangle of, this is 6, 8. So I can take it as 3 and 4. So it's going to be 3, 4, 5. Okay. Summation of forces in X direction equals 0. Anything that points towards right is going to be plus. I start from FDE. The X component of it is 3 over 5, pointing opposite direction to my sign. That's minus. The 600 is also minus. And FCD is in Y direction, so I don't care about it. And that's 0. This will result in FDE of minus 1000 newtons. Okay. I drew my unknown force in tension. It turns out to be negative, meaning I should have drawn it the other way, meaning it wasn't in tension, so therefore it was in compression. And that was a good thing. That is one of the benefits of drawing unknown forces in tension all the time. If you get a negative, automatically you can just call it tension. Some people like to write it this way. FDE equal 1000 Newton or 1 kilonewton compression. Same way. Same thing. Okay. Second equation that I have, summation of forces in Y equals 0. I start with FDE. Y component of it is 4 over 5. It's pointing down, so it's negative. Minus FCD equals 0. FDE, I found it to be minus 1000 newtons. That's important. When you want to substitute it in the next equation, you have to put everything with the minus sign in it, okay? Because remember, now we know that this force was actually pointing the other way. So it's like it's a positive value. And if you look at this whole thing is going to be positive, which makes sense. Okay? And this will result in FCD of being 800 newtons. I drew this force in tension. My sign turned out to be positive, so that means it is in tension. Okay? Alright, so I found this force to be 1000 newtons tension. I found this one to be 800 newtons. Or sorry, this one was compression and this one was tension. Let's move on to point C. So now I'm going to draw a free body diagram of C. Joint C. Step 1, isolate. Put active forces. Put reactive forces. There is one tension force of 800 newtons. See, now that is a known force. That I have to pay attention to the direction of it. It is a known force of 800 and tension, meaning going away. So 800 newtons tension. I have a force CE. That's an unknown. That I can draw it in tension. FCE. And then I have another unknown force of CB, which I draw that one also in tension. So unknown, I always draw it in tension. The known one, such as this 800 or that 900, I have to put the direction which they're pointing. Summation of forces in Fx equals 0. Anything that points toward right is positive. I have minus FCE minus 900 Newton equals 0. FCE equals minus 900 newtons. It's a minus, that means it's a compression. Okay, summation of forces in y equals 0. Anything that goes up is positive. I have an 800 Newton pointing up. I have minus FCB equals 0. So FCB is going to be 800 newtons. It's plus, so I'm going to put tension in it. Okay, let's move on to pin E. Drawing free body diagram of pin E. That is going to be my pin E. I have a known force of FDE. Let's look back here. FDE is 1000 Newton and it's a compression. FDE is 1000 Newton compression. Compression means pointing to the pin. It's a compression force of 1000 newtons pointing to the pin. I have F force of EA. Let's go back here. I have one force in the direction of EA. That's an unknown force for me, so I'm going to draw that as tension. I have, I have unknown or known force of EC. Known force of force CE, and that's compression 900. That is pointing to the pin or to the joint. And I have unknown force of EB. So it's in the direction of EB. It's unknown, so I'm going to put it in tension. So these two were known from free body diagram of D and C that I already did. These two, EA and BE, these two were unknown that I am trying to find. So let's find the slope for them as well. This is also 3, 4. So this is 3, 4. And the other one is also 3, 4, going this way. All right. Summation of forces in x direction being 0. So force EA minus, it's going to be 3 over 5. Force BE, that is plus, it is going to be 3 over 5. Um, 900, that is minus. That 1000, it's 1000 newtons, 3 over 5. That one is also minus, equals 0. That's one equation. My second equation, so summation of forces in y direction. Force EA pointing down, and that is going to be 4 over 5. Force BE, 4 over 5. And 1000 newtons, 4 over 5 equals 0. If you do the two equations, two unknowns, we're going to get FAE or EA of minus 1750 newtons. That's minus, so it's going to be compression, or I can say 175 kilonewton compression. FBE is going to be 750 newtons. That's plus, so that is going to be tension. Okay. Let's look at another example. For the loads shown on the truss, use method of sections to find forces in members KJ, KD, and CD. KJ, KD, and CD. The first step is to decide where to make a cut. It's method of sections, so I need to make a cut. I will make a cut that goes through all of those points. So I'm going to make a cut right here. And that will divide my truss into two halves. And then you got to pick one side to draw a free body diagram off. Okay? I will pick this side to draw a free body diagram off. And this is the free body diagram of my section. Okay. Okay, this and this. This is K, this is C, this is B, this is L, and this is A. Active forces, I have 30 kilonewton at point C. I have 20 kilonewton at point B. Reactive forces are going to be forces that are unknown. The first one I see is at point A. This is a pin. If you remember from previous lectures, pin has an AX and AY. And remember, when you make a cut in any member, you reveal the internal forces. And since they're all unknown, I'm going to put all of them in tension. FKJ, FKD, FCD. Okay. How many unknowns do I have? Let's see. 1, 2, 3, 4, 5. I have 5 unknowns. As far as I know, I only have 3 equations: sigma fx, sigma fy, and sigma moment. So I need to go back one step back and find ax and ay. To find ax and ay, I treat this truss as a rigid body diagram, meaning I draw the free body diagram of entire thing, so FBD of entire truss. Okay, step 2, put active forces on there: 20, 30, 40. Put reactive forces, put AX, AY for a pin, and I put GY for a roller. Now I have 3 unknowns. I will use sigma summation of forces in x direction being 0. This will result in AX being 0. So this is 0. Summation of moment about G being 0. I'll skip the math. It will give you AY of 56.7 kilonewton. So AY 56.7. If you want, you can also use summation of forces in y equals 0 and get GY of 33.3, but we don't need it. We only needed AX and AY. All right, so now back to our free body diagram of the section. So let's see. Now I have 3 unknowns. Okay, now I have sigma fx, sigma fy, and sigma moment. Let's see. I'm going to use sigma moment, summation of moment about what point? If you remember, I told you that you can take summation of moments about any point. I like to take about point D, which is here. So this one is FCD. Okay, point D, that as you can see is not even on the free body diagram, but I picked that point because FCD and FKD, they both go through point D, so the distance between point D and line of action of those forces are 0, so I don't need to worry about it, so I can find my FKJ. So let's see. I have, starting from AY, I have a 56.7 multiplied by the distance between point A and point D, 2, 2, 2, that's 6 meters. AY is trying to rotate this whole thing clockwise about point D, so I'm going to put negative there. The next one that I have is 20. The distance between that point B and point D is these two added together, so that's 4 meters. 20 is trying to rotate this counterclockwise, so that's plus. The next force I see is 30. The distance between point C and point D is 2 meters. Same direction as the 21, so that's plus. And the last force that I have is FKJ. The distance between that force, point D is here, FKJ is right there. The perpendicular distance between point D and that line of action of this force, which is this line, this is the distance, which if you look on the diagram is 3 meters. And this force is trying to rotate this whole thing clockwise around point D. So that one is also negative, and that will equal 0. The only unknown here is FKJ, which I'm going to write it next to slide. FKJ is going to be minus 66.7 kilonewton. Let's go back and see. I drew FKJ in which way? It's going away from the pin, so it is in tension. I drew it in tension because it was an unknown. I got a negative. Negative means it is actually compressive force or in compression. So this, I can put a C next to it, say, hey, this is compression. All right. So FKJ is taken care of. Let's do sigma forces in y direction. Summation of forces in y direction is 0. I have a 56.7 pointing up. I have a minus 20. I have a minus 30. I have a FKD, the y direction of FKD. So FKD is like this, FKD, and how much is coming down? 3. How much is going to the side? 2. Okay, so the y component of it, first of all, it's minus, pointing down. It's going to be FKD 3 square root of 13 equals 0. This will result in FKD of 8.05 kilonewtons. Okay, and the last equation I have, summation of forces in x is 0. I have a minus 66.7 kilonewton, this force that I just found with the sign and everything, put it in the equation, plus FKD. This time we're looking at 2 over square root of 13, and this I just found it to be plus 8.05, and the last force that I have is FCD equals 0, and this will result in force CD being 62.2 kilonewton. It's a plus, so it's going to be tension. That one was tension too, by the way. Okay, so those are the 3 forces that I was interested in. Let's look at another one. Use method of joints and determine forces in each member of the truss shown. State whether each member is in tension or compression. Okay, so I got to start from a joint that has 2 unknowns. Hey, by looking at this truss, do you think it's a symmetrical truss? Meaning force in AB is the same as force in BC? Because everything looks symmetrical. 7 on that one side, 7 on the other side, 24 in the middle, 8 in the middle. Each side has 1.5. So what do you see in here that makes it not a symmetrical truss? Yes, if you look at these, this is a roller, this is a pin, and those have different reaction forces. So this is not symmetrical. But let me find the reaction of supports here. To find reactions, we treat this as a rigid body. Step 1, outline of the shape without any supports or anything. Step 2 is active forces, 24, 7, 8. Step 3 is reactive forces. Pin has Fx and Fy, and roller has just a vertical component, dy. Let's see. If I write summation of forces in x direction is 0, the only force I see in x is Fx. So this is 0. So now look at it. So yes, it turns out this was symmetrical because there's nothing in x direction, and everything to me looks symmetrical. So let's see. If I write summation of forces about D or about F, doesn't matter, about D equals 0, I get Fy of 23 kilonewtons. If I use summation of forces in y direction equals 0, I get dy of 23 kilonewtons. So yes, indeed, this was a perfectly symmetrical truss. So if I find forces in half of the members, the other half should be the same. So let's start. So now we're just starting with this problem. Free body diagram of joint A. Draw joint A, put active force there, and then put reactive forces, two forces, both in tension, FAB, FAD. Okay. Summation of forces in X equals 0. FAB is 0. Summation of forces in Y equals 0. Minus 7 minus FAD equals 0. FAD is minus 7 kilonewton, and that is compression force. Okay, so I found this one and I found AD. Okay, which one do you want to move next? Let's move on to joint D. FBD of D. Okay, draw joint D. Every force that I see is reactive force. So let's see. There's a dy that I found it here. It's 23, and I found the direction of it. So 23. I found AD. I just found it to be 7, to be compression, meaning coming towards the pin, towards the joint. 7 kilonewton there. I have FDB. This one is unknown, so I'm just going to draw it in tension, which I have what? Let's see, 8, 15. So this is going to be 17. Or 0.8, 1.5, 1.7. It's a triangle, it's a ratio, so it doesn't matter. And a DE that is horizontal. So let's see. Let's start with sigma Fy equals 0. Summation of forces in Y equals 0. Minus 7 plus 23 plus FDB 8 over 17 equals 0. So this will give me FDB of minus 34 kilonewton. I got a minus. That means it's compression. Summation of forces in X equals 0. I have a FDB, so minus 34. See, I bring the whole thing with the minus. FDB, which is minus, and this is sigma Fx, so I'm looking at 15 over 17. Plus FDE equals 0. So FDE should be plus 30 kilonewton, and this is a tension force. The last one that I want to do is point E, FBD of point E. So here we go. Point E, active force of 8 kilonewton. I have BE, which I haven't found yet. BE. I put it in tension because it's an unknown, going away from the pin. I have DE, which I found to be tension 30. Tension and 30. And I have EF, which is unknown. I put it as tension force of EF. Okay, this looks simple enough. Summation of forces in Y equals 0. FBE should be 8. Summation of forces in X is 0. FEF equals 30 kilonewton. They're both tension forces. If you want to continue, you can draw free body diagram of point D, find these two, but it's going to be similar to AB and AD, and you can draw free body diagram of pin D and find CF, which is going to be similar to AB. Let's look at another one that is a little bit more complicated, or at least the figure looks a little bit more scarier. Find the forces in member ED, EF, and GH, and state whether they are in tension or compression. See, it doesn't tell us what method to use, but what would you choose if you wanted to choose between method of joints versus method of sections? Let me mark the members that I'm interested: ED, EH, GH. See, kind of see the trend there? So if I make a cut right there, it will reveal those forces to me, that imaginary cut. So therefore I can use method of section. So use method, let's go with method of sections, because with method of joints it's going to be too much. You have to draw too many free body diagrams of different joints. The other thing is, now you have a choice. You have to take this half or this half. The left side looks simpler to me, you know, so I'm going to draw a free body diagram of the left side. Point E has a 40 kilonewton. Now, do you see I don't draw the half cut members here, ED or EH or GH. I just want to have a simpler free body diagram. Or I should say more clean free body diagram. That's point G, that's point F. Point F is a roller, so it has an Fy. Now the active forces, or sorry, the reactive forces are three forces that I'm looking for: ED or FED. Let's just put FED so everyone is clear what we're looking for. I have FEH and I have FGH. Okay, 3 unknowns. Nope, I have 4 unknowns. I have Fy. So I need to go one step back. I need to go find the free body diagram, draw the free body diagram of entire truss to find the support reaction. Outline. I don't need to draw all the members and all the details and stuff, right? So just a rough outline, the best you can. Okay, that's the outline. Active forces, which I have plenty. I have a 40 here, I have a 50 here, I have a 30 here, and I have a 40 here. Okay. Reactive forces. F is a roller. Fy. Remember, that was the whole thing that I started going back here. And AY and AX. Because point A is a pin. Alright, so now, listen to me. Now you got to be smart. All we need is Fy. Is all we need. So you have to kind of plan your equations here. So don't find the reactions that are unnecessary and you don't need them. AX and AY, I don't care about them. So if I take moment about AX, AY, they go through it. 50 kilonewton on top, it goes through it. So all I have left is Fy, the 40, 30, and another 40 to write. So I'm going to kind of write it quicker here. Fy, distance between line of action and point A. This distance here is going to be 2 and 2, 4. So it's Fy 2 plus 2. And it's trying to rotate it counterclockwise. So it's going to be minus. Then I get this 40. The distance between that one is only 2. So it's going to be 40 kilonewton, 2 meters. And then I have a 30. Distance between point A and line of action is right here, which is 3, 1.5, 1.5. So I have a 33. That's a plus, trying to rotate the whole thing counterclockwise. And the last force I have is distance between point A and line of action of this force. This distance right here, which is 1.5 meters. So 40, 1.5 meters, kilonewton meters, and that's also plus. So this will give you F sub y of 57.5 kilonewton. 57.5. Okay, that's all I care about. So now I have 3 unknowns: ED, EH, and GH. The 3 that the problem asked me to find. Okay. I usually like to start with a moment, and I'm gonna take moment about point, let's see, point E. If I take moment about point E, look, the 40, the ED, the EH, they all go through point E, so I don't need to worry about them. Moment about point E being 0. All I have is Fy, which is 57.5, at a distance of, how much is that? 2 meters. And it's trying to go against my sign, so that's negative. The next force I have is FGH, multiplied by the distance between E and line of action of GH, which is 1.5 meters. And that one is trying to rotate this whole thing with my sign, so that's plus, equals 0. This will get me FGH of 76.7 kilonewton. It's a plus, so I have a tension. All right. Let's do summation of forces in Y equals 0. Okay. I have a 57.5. I have a minus 40. I have a minus EH, and we are looking at 3/5. Okay, force EH is like this, FEH. It's moving to 1.5. So it is like 4 and 3, same ratio. So it's 3/4/5. I use 3/4/5 because it's a very common ratio, and I know what to expect. Otherwise, this is 1.5. Based on my figure, this is 2. Okay, same ratio. So 3/5 equals 0. So this will get me FEH of 29.2 kilonewton, and that means also tension. And last equation that I have is summation of forces in X equals 0. Okay, and that means 76.7 plus 29.2. I'm going a little bit faster. 4/5 plus FED equals 0. Summation of forces, FED is going to be minus 100 kilonewton, and that means it is compression. Okay.